Welcome. In this lecture, we're going to kind of put together all the things we've learned that we can get from the first derivative. So here's the example, or our task. So here's our task, which is going to be and then we have our function is going to be f of x equals, and we have 2x cubed. And then this is going to be plus 9x squared. And then minus 12x plus 1. Okay, so then we have two things we want to do. So the first thing that we want to do, so for A, we want to we just want to find the derivative. So find the derivative with respect to x of f, so that's a function where we're going to want to find it. And then for b, we're going to indicate on the number line, so indicate on the number line where we have, so there's where, and we're going to want to know where, so we have the derivative, so we want circumstances where this derivative that we found there, so this derivative, we want to know where it's going to equal 0. So where is it equal 0, where is it less than 0, and where is it greater than 0. Okay, so it's kind of a number of things that we're going to want to do, but we can do those. So let's get started with the first part, which is just to find the derivative. Okay, so we have f of x equals 2x cubed plus 9x squared minus 12x plus 1. Okay, and then I'm just going to find the derivative of that. So f prime of x. Okay, well, how do we figure out what that is? Well, it's going to equal, well, we have to drop down the 3 and multiply that by 2, so we're going to get 6 there. I'm trying to decide what color I want to use now. So I'm going to get a 6, and then I'm going to get an x squared. So 6x squared, right, because I just subtract 1 from there. So 6x squared, right? I multiplied 3 times 2, that's how I got the 6. I had to subtract 1 from there, that's how I got the 2. And then I need to add to that, so now I need 2 times 9, so that gives me 18. And then x, I subtract 1 from 2, so I get x to the 1, which is just x. Good? Okay, and then for this one, right, we just end up with the constant there, so we get minus 12. And then when you take the derivative of a constant, you get 0. So we're done with this. Okay, perfect. Now the next part is we actually need to find where the derivative is equal to 0. Okay, so for completing step this, the first thing that we need to do is to find where the derivative is actually 0. Otherwise, we can't divide it up into those 3 circumstances. So the first part, or step 1, okay, so this is like step 1, is going to be to find where this f prime of x is actually equal to 0. So where does f prime of x equal 0? Okay, like where is that its output? Okay, so we're looking at where this equals 0. So let's go ahead and kind of write that there. So we have 6x squared plus 18x minus 12, and then we want that to equal 0. Okay, so I just rewrote the derivative from here. I wrote it here, and then I set it equal to 0 because this is what we're looking for. And now we can pull out a 6, which is going to make this much easier on ourselves. It's always good to look at what you can pull out first. So I have 6, and then I have x squared And then I have to pull a 6 out of each term. Don't forget that. So I actually also have to pull a 6 out of here. And 6 times 3 is what gives me 18. So how do I get 12? So 6 times minus 2. So that's just going to end up being minus 2. And this still equals 0. All I did was factored or pulled out a 6. But I'm going to continue with my factoring. Because right now I need two things that multiply to this and add to. Oh, this should not be a minus. Is this not supposed to be a minus? I have a typo that's been living here for a while now. This is supposed to be a plus. So this is supposed to be a plus. So this is supposed to be a plus and a plus and a plus. There we go. I need two things that are going to multiply to this and add to this. Now this is possible. Oh gosh. I didn't mean to have something that doesn't factor over the real numbers. So this does. So I'm good. Okay. Again, I need two numbers that multiply to this and add to that. So I'm going to, wait, so they're going to be 2 and 1. So got my plus 2 and my plus 1. This still has to equal 0. So now, right, this can't equal 0, but each of these can equal 0. So this gives me that x, so this will give me x equals -2, right? So this one here is 0 when x equals -2, and this one here is 0 when x equals -1. Okay, so where I'm at is that this derivative this of x equals 0 when, so I get that this equals 0 when, so I get these two values here, right? Okay, so when x equals -1 and -2. Okay, so now I'm at a place where I actually have stuff to work with over here. So let's go ahead and start with that. So I'm looking at, let's think of this as like, okay. Right, this is like I can think of this as being my x-axis, but then my f prime is above it. So maybe we'll write f prime like here to indicate that the f prime is what I'm going to be drawing above it. Okay, now I know that the two most important parts here are -1 and -2. This is when things are going to get different, so I'm going to put those on here. So -2 and -1. Okay, so why did I actually do this? I didn't actually kind of emphasize that, but let's do that now. I mean, one is I'm kind of dividing it up here, but I'm also, this is going to be, these are my only, it's where I can switch sign between positive and negative. These are also going to be the only critical numbers because this is a polynomial. Okay, so maybe I'll actually note this here, which is that these are where my critical points are at. So if I'm looking for any switches of increasing or decreasing, or whether I'm looking for local maxes and local mins, this is where I've got to like kind of divide things up and then look at these for the local maxes and the local mins. Okay, so what do we need to do here? I need to test, right? I need to test whether the derivative is greater than or less than 0. Okay, and this is my derivative. It's easiest where it's factored. So we're going to look at this part, and then you just need to look at the sign. Okay, so what we're going to do here is we're going to test. Okay, so test whether we're going to test the f prime sign at x equals -3. Okay, so what I'm going to do is I'm going to put this into here. And so I have 6, so that's positive, so that doesn't impact anything. And then I have this, so this is going to be, if I put in -3, this is -1, so that's negative. And then I'm going to put minus 3 into here, so I'm going to get minus 2, which is also negative, and 2 minuses multiply give me a positive. So this tells me that my derivative, I'm going to do my derivative like this, okay, that my derivative must be increasing here, okay? Great. Now I am going to look at what happens here. And I've got, so now I'm going to test at like something between these two, so at minus 1.5. Okay, so now we're going to test the f prime sign at x equals minus 1.5, and let's see what happens. So positive, if I put minus 1.5 into here, then I'm going to get something that's positive because minus 1.5 is smaller than 2, so it's not enough to bring it down to negative. This one does become negative. Like minus 0.5. So this is actually going to be negative. So my derivative is actually going to be going, so my function is going to be going down there. I'm going to draw this slightly. I'm going to put, so this is my derivative down here. This is what's happening with my derivative down here. When I'm drawing up there, I'm actually drawing my function as it's my function that's increasing and my function is decreasing. This is kind of a better system. So then when we get to over here, we want to test. So we want to test f prime. We're going to test its sign at x equals, so we take another number that's in this interval that's, you know, kind of easy to do. So we do this at x equals 0. So we have 2, which is positive, and 1, which is positive. So we go plus times plus, which is positive. So we know that we're increasing there. Okay. So then what we can do is we can actually look at, like just looking at this picture, we can tell there's a local min here and a local max here and a local min there. Okay, so we have a local max here. And we have a local min here. So if I wanted to actually figure out what the local max value is, right, I can just kind of put that in. So I can take f of minus 2, right, and I get that by plugging it into my original function, and I would get out minus 3, so this would equal minus 3. Okay, so that gives me a local max, so this is a local max. And here I'm going to take f of minus 1. And this is going to give me out, this is going to give me out minus 4. Okay, so this is going to be a local min. Right? And that is kind of telling me my graph is roughly going to look like, you know, going up and down like this, where this is a low point here and that's a high point there. Okay? So I hope that made some sense, and I will see you in the next lecture.